Dear students, under the topic integer linear programming, here we are going to learn another algorithm which is known as the cutting plane algorithm. Already we have learned the branch and bound method in order to solve an integer linear programming problem. Now this cutting plane algorithm will also start at the continuous optimum linear programming solution. That is, for this given problem, first we have to find the optimum solution. And when the optimum solution are not integers, then we have to apply the cutting plane algorithm in order to obtain the integer solution. The basic knowledge that will be required is the simplex method algorithm and the dual simplex method algorithm. But anyway, in this lecture, I will be doing even the simplex method and the dual simplex method exhaustively. The video may be a bit longer for that reason. Those who know the concept of simplex method and the dual simplex method may quickly process the video and they may look into the main concept that is required. Anyway, first of all, we will solve this given problem by using simplex method algorithm and we will find the optimum solution. And when the optimum solution are not integers, we will be adding special constraints which will be called as cuts. And these constraints will be added to the solution space in a manner that it will render an integer optimum solution. So let us proceed the problem by using simplex method algorithm. The question here is, solve the following integer linear programming problem by using cutting plane algorithm. The question is to maximize z equal to 7x1 plus 10x2 subject to the constraints minus x1 plus 3x2 lesser than or equal to 6 and 7x1 plus x2 lesser than or equal to 35 given that x1 and x2 are greater than or equal to 0 and integers. So now in order to solve this problem, first we have to, whenever a question is given, we have to check whether it is a minimization or a maximization problem. If it is a maximization problem, then directly we can proceed it. If it is a minimization problem, then we have to convert it into maximization problem with the required procedure and then we have to proceed it. So now here the given problem is of the maximization type. So we have to first write the standard form of the given LPP. So let us write the standard form. By writing it into a standard form, we will be converting these inequalities into equalities by adding slack variables. Since the inequalities here both are lesser than or equal to, we are going to add slack variables S1 to the first constraint and slack variable S2 to the second constraint. And the slack variables will also be added to the objective function with 0 coefficients. So let us convert this given problem into a standard LPP first. So the standard form of the LPP is obtained here. Now to the first constraint we have added S1 with coefficient 1 and S2 with coefficient 0. To the second constraint S1 with coefficient 0 and S2 with coefficient 1 so that they form the matrix 1 0 0 1. And these slack variables are also added to the objective functions with coefficients 0. When these x1 and x2 are known as non-basic variables and s1 and s2 are known as basic variables. Now we shall first find the initial basic feasible solution and it is obtained by putting x1 and x2 is equal to 0 initially. So the initial basic feasible solution is obtained by putting x1 comma x2 is equal to 0. Now if we put x1 and x2 as 0 in the first constraint, we get s1 to be equal to 6. So we get s1 to be equal to 6. And if we put x2 as 0 in the second constraint, that is x1 and x2 as 0 in the second constraint, we get s2 to be equal to 35. So these are the initial basic feasible solution, where s1 and s2 are basic variables and x1 and x2 are non-basic variables. So after obtaining the initial basic feasible solution, the next step is the construction of the simplex table for the given problem. So first we have the initial iteration. Now here, first we shall fill this YB column. It is the basic variables that we have added to the question. That is, what are the basic variables? S1 and S2 are the basic variables. So that we have to write here. So S1, S2. And the cost of the basic variables in the objective function, that is, both are 0. So that we have to write here. And then xb is the column which are the solution of the basic variables. That is, the initial basic feasible solution are s1 is 6 and s2 is 35. So that we have to write here. So s1 is 6, s2 is 35. And Cj gives us the cost of these variables. That is, x1 and x2 are non-basic variables and s1 and s2 are basic variables. And cost of these variables in the objective function, that is, for x1 it is 7, x2 it is 10, s1 is 0 and s2 is 0. So these values we have to write here correspondingly. So 7, 10, 0 and 0. And inside this we have to write the matrix which gives us the constraints. That is, the coefficients of x1, x2, s1, s2 we have to write in the first row. So minus 1, 3, 1, 0. So here we have to write minus 1, 3, 1 and 0. And the coefficients from the second constraint, that is the constraint that is 7, 1, 0, 1. So that we have to write in the second row. So 7, 1, 0, 1. So the next step is we have to find Zj minus Cj. So what is that? Zj minus Cj is obtained by multiplying the cost value, that is 0 multiplied with 6 plus 0 multiplied with 35. So it is 0 only. And 0 multiplied with minus 1 plus 0 multiplied with 7, both are 0. Minus, you have to write minus 7. So minus 7. This 0 into 3 plus 0 into 1 minus 10. 0 into 1 plus 0 into 0 minus 0 is 0. Again this also 0. Those who know the simplex method algorithm will easily understand this. So kindly observe carefully. You have to multiply the cost with these values and then add it and then subtract the cost that we have written at the top of the table. So after this we have to find for the most negative value from the Zj minus Cj. So what is the most negative over here? Minus 10 is the most negative. So that will be the entering variable. So what is the variable corresponding to it? x2. So x2 will be the entering variable. Now we have to find the leaving variable, for which we have to find the ratio. So how this ratio is done? The solution space has to be divided by the corresponding entering column element. So this is the solution space. So this is the entering column. So 6 divided by 3 is the first ratio and that is equal to 2. And then 35 divided by 7 is the second 35 divided by 1, not 7. It is 1 over here. 35 divided by 1, which is equal to 35. So which is the least of these two? 2 is the least. So the leaving variable will be S1. So S1 leaves the basis. So this will become the leaving column. Row. So this is the entering column. This is the leaving row. So S1 leaves the basis and X2 enters the basis. And this element 3 is known as the pivotal element. It is also known as the key element. And this row is known as the pivotal row. And this column is known as the pivotal column. And 3 is the pivotal element. Now we shall do iteration 1. So now we are going to perform the row operations and we are going to do iteration 1. So in order to perform the row operations, we must first know these two formulas. That is, the new pivotal equation is equal to old pivotal equation divided by the pivotal element. So first we shall write this. What is the new pivotal equation? It will be the column corresponding to this one. That is, S1 is the pivotal row. So this, the row that we are going to find corresponding to this is known as the new pivotal equation. So now the values of yb will be, now since x2 is entering the basis and s1 is leaving the basis, at the place of s1 we have to replace it by x2. So this has to be replaced by x2. S2 will remain as it is already. Since s1 has left, at the place of s1 we have to replace it by x2. And after replacing, the corresponding cost from the objective function that we have to take and write. So the cost of x2 in the objective function is 10. So that we have to take and write here. And the cost of s2 is 0 only. And the values of cj as usual 7, 10. And for this one, s1 and s2, it is 0. That also we have to write. Now these values we have to evaluate. Now in order to evaluate that only, we are using the formula that I showed you. So if we are considering the initial iteration first row as R1 and this as R2, and from the while forming the new table, we shall consider this row as R1 dash and this row as R2 dash. Now first the pivotal row we will see. So first row is the pivotal row. So R1 is the pivotal row. Now here the new pivotal equation will be R1 dash, and we saw that from the formula that the new pivotal equation is equal to old pivotal equation divided by the pivotal element. What is the old pivotal equation? So new pivotal equation R1 dash is equal to the old pivotal equation is R1. So R1 divided by, what is the pivotal element over here? 3. So divided by 3. So this is how we have to form R1 dash. And what about R2 dash? It is obtained by using this formula. That is, we are going to find new S2 equation. That will be equal to old S2 equation. What is new S2 equation? It is R2 dash. Old S2 equation is R2. And then minus. So if you see, we have minus over here. Minus corresponding element of the pivotal column. So what is the corresponding element of the pivotal column? This is the pivotal column, and for S2 the corresponding element from the pivotal column is 1. So 1 multiplied with, so what is the formula? 1 multiplied with new pivotal equation. New pivotal equation is this one that we are going to find, which is R1 dash. So 1 multiplied with R1 dash. So this is how the formula will be. So R2 dash will be equal to R2 minus the corresponding element from the pivotal column multiplied with the new pivotal equation, that is R1 dash. So now first we shall find R1 dash, which is equal to R1 divided by 3. So this is R1. So all the elements of R1 has to be divided by 3. So 6 divided by 3 is 2. And then, so that we will write here. So 6 divided by 3 is 2. Then we have minus 1. So minus 1 divided by 3 will be minus 1 by 3. And then 3 divided by 3 is equal to 1. Since that is the pivotal element, we have to make it 1. And 1 divided by 3 will be 1 by 3. So 1 divided by 3. And then we have 0. So 0 divided by 3 will be 0 1D. So we have found R1 dash. The next step is we have to find R2 dash. Now what is R2 dash? It is R2 minus R1 dash. So let us do this operation separately and we will check. First we will take and write the elements of R2. What are the elements of R2? That is the equation from this. This is R2. So first we have 35. So that we will write. Then 7 and then 1 and then 0 and then 1. So this is the row R2. Next we want R1 dash, because R2 minus R1 dash. So we will take and write R1 dash. What is R1 dash? It is the new, these elements are R1 dash. So 2 and then minus 1 by 3, 1, 1 by 3, 0. The formula is actually R2 minus R1 dash. So subtract this. So R2 minus R1 dash we will do. So 35 minus 2, which is 33. Then 7 minus 1 by 3. So what is 7 minus 1 by 3? 3 is the LCM. 3 7 times is 21. I mean, and actually this is r2 minus r1 dash, so minus into minus will become plus. So 7 plus 1 by 3, so 21 plus 1, so it will be 22 by 3. And then 1 minus 1, 0. Then 0 minus 1 by 3 will be minus 1 by 3. 1 minus 0, 1. So these are the elements of the new row r2 dash. So let's take and write them here. So first is 33, and then 22 by 3, then you have 0, then you have minus 1 by 3, and then you have 1. So next step is we have to find Zj minus Cj. So after finding these rows, we have to find Zj minus Cj, which is 10 into 2 plus 0 into 33. So 10 into 2 is 20. And then similarly here, 10 into minus 1 by 3 is minus 10 by 3. And then minus 7 we have to do. So actually minus 10 by 3 minus 7. The LCM is 3. So minus 10 minus 3 7 times is 21. So it will be equal to minus 31 divided by 3. So this is minus 31 divided by 3. Then 10 into 1 minus 10. So 0. Since this is 0, I haven't calculated for that. Then 10 into 1 by 3. 1 by 3 is 10 by 3 minus 0. So it will be 10 by 3. And then 10 into 0, 0 into 1, anyway this is going to become 0. Now the most negative enters the bases. We have only one negative value, which is minus 31 by 3. So x1 enters the bases. So this becomes the entering column now. In order to find the leaving row, we have to find the ratio. Now in order to calculate ratio, we have to calculate only for positive values in this column. This value is negative, so we need not calculate the ratio, so hyphenate it. And then for this, the ratio is 33 divided by 22 by 3. So that can be written as multiplied with 3. This is 11 3 times, 11 2 times, which is 9 by 2. And this leaves the basis. Since it is the only value, S2 leaves the basis. So x1 enters and S2 leaves. Now at the place of S2, in the next iteration, we have to replace it by x1. So this becomes the leaving row. And what is the pivotal element? 22 by 3 is the pivotal element. So kindly do the calculations little carefully. So x1 enters the basis and S2 leaves the basis. So now we shall perform iteration 2. Now we have to write the column YB first. Now x2 remains as it is. S2 leaves the basis and x1 enters. That is what we saw. S2 leaves and x1 enters. So at the place of S2, we have to replace it by x1. And what is the cost of x2 and x1 in the objective function? For x2 it is 10 and x1 is 7. So we have to fill in that cost. So here it is 10 and here it is 7. And then now Cj is as usual 7, 10, 0, 0. Now we have to find the remaining elements by using the row operations. So if we take this as row 1 double dash and this row as row 2 double dash. Now first we have to see what was the pivotal row over here. Row 2 dash was the pivotal equation. Now we know that the new pivotal equation will be equal to old pivotal equation divided by the pivotal element. What is the old pivotal equation? It is R2 dash. New pivotal equation is R2 double dash, which we have to find. So new pivotal equation R2 double dash is equal to old pivotal equation R2 dash divided by, what is the pivotal element? It is 22 by 3. So we can say that it is 22 by 3. And what will be R1 double dash? It is the new x2 equation. The new x2 equation will be equal to the old x2 equation, which is R1 dash minus the corresponding pivotal column element. So this is the pivotal column. For x2, what is the corresponding pivotal column element? Minus 1 by 3. So minus into minus will become plus 1 by 3. And then we have to multiply with new pivotal equation. What is the new pivotal equation? R2 double dash. So that is the formula. Now using these row operations, we have to fill in these rows. Now first we will find R2 double dash, for which we should know what the row R2 dash. So this is the row R2 dash. The elements of these row of this row has to be divided by, here we have, that is, divide all these elements by the pivotal element, that is 22 by 3. So when we divide, what we get is, we get the new pivotal equation R2 double dash, where we get it to be 9 by 2, 1, 0, minus 1 by 22, 3 by 22. You can do and check it out. Just a division of R2 dash by 22 by 3. So this is the resulting new equation of R2 double dash. Now we shall find R1 double dash, for which first we will take and write R1 dash. So from this, R1 dash is given by this equation. So we will take and write this 2 minus 1 by 3, 1, 1 by 3, 0. So we will write it first. So I have taken and written R1 dash over here. And this has to be added to, so plus 1 by 3 R2 double dash. So 1 by 3 R2 double dash. So we have to multiply R2 double dash with 1 by 3 and we have to write here. So this is R2 double dash. So this equation has to be multiplied with 1 by 3. So first we have 9 by 2 over here. When 9 by 3 is multiplied with 1 by 3, we will get 3 by 2. So we will write 3 by 2 over here. Then 1 has to be multiplied with 1 by 3. 0 into 1 by 3 is 0. Minus 1 by 22 multiplied with 1 by 3 will give us minus 1 by 66. 3 by 22 multiplied with 1 by 3 will give us, 3 will get cancelled and we will get 1 by 22. Now we will add these two. So when we add 2 plus 3 by 2. So what is 2 plus 3 by 2? It is, 2 is the LCM, 4 plus 3. So that will be 7 by 2. So here we will get 7 by 2. And then minus 1 by 3 plus 1 by 3 becomes 0. 1 plus 0 is 1. 1 by 3 minus 1 by 66. So 1 by 3 minus 1 by 66. 66 will be the LCM and this has to be multiplied with 22. So 22 minus 1, which will be 21 by 66. And on cancelling, 3 7 times and 3 22 times. So 7 by 22. Here we will get 7 by 22. And 0 plus 1 by 22 is 1 by 22. So this is the new R1 double dash equation. So let us take these values and we will write over here. So I have taken and I have written that over here. Now next we have to find Zj minus Cj. So for this column it will be 10 multiplied with 7 by 2. So 2 5 times is 10. So 7 5 is 35. So 35 plus 7 multiplied with 9 by 2. 7 9 times is 63 divided by 2. And so the LCM will be 270. 35 into 2 is 70 plus 63, which will give us 133 divided by 2. So 133 divided by 2. Then 10 into 0 plus 7 into 1 minus 7. So 7 minus 7, it becomes 0 over here. 10 into 1 plus 7 into 0 is 0. So 10 minus 10 is 0. Then 10 in multiplied with 7 by 2, which will be 70 by 22. So 70 by 22. And then minus, because 7 into minus 1 by 22. So 1 by 22 will be minus 7 by 22. So that will be 70 minus 7 is 63 by 22. And on cancelling, here we will be having, no, we can just write it directly. So 63 by 22. And here we have 10 multiplied with 1 by 22, which will be 10 by 22 plus 7 multiplied with 3 by 22. So 3 7 times is 21. So 21 divided by 22. So when we add, we get 31 divided by 22. So we see that all the zj minus cj, so all zj minus cj is either greater or equal to 0. So we have attained the optimum condition. So we see that all zj minus cj is greater than or equal to 0, and hence the optimum solution is obtained. So what is the value of, from the solution space we see that the value of x1 is 9 by 2. So we have to take and write that. So the value of x1 is equal to 9 by 2. What is the value of x2? It is 7 by 2. So x2 is equal to 7 by 2. And the value of z is equal to this one, 133 divided by 2. So we see that though the optimum condition is obtained, the values of x1 and x2 are not integers, rather they are fractions. So now here comes the integer programming problem. Now since x1 and x2 are not integers and they are fractions, we have to construct the fractional cut, and we have to redo this problem in order to obtain integer solutions for x1 and x2. So now we continue with the procedure of integer linear programming problem by using cutting plane algorithm. So now here we have the construction of the fractional cut 1. So first, if you see, the first solution x1 is equal to 9 by 2. So let us take and write that. So x1 is equal to 9 by 2. Now this we have to first check whether the numerator is greater than the denominator. If it is greater than the denominator, then divide the numerator by the denominator. So 2 4 times is 8, and the remainder is 1. Now 9 by 2 can be written as a mixed fraction. How the mixed fraction we will write? Quotient and then the remainder divided by the divisor. So it can also be written as 4 plus 1 by 2. That is quotient plus remainder divided by the divisor. It can be written in this form. So this 9 by 2 can be written as 4 plus 1 by 2. 2. And so this is equal to, the integral part is xb1 is represented like this 4, plus the fractional part is represented as f1, and then x2, the second solution. What is the second solution? x2, it is 7 by 2. So 7 divided by 2. Again we have to check whether the numerator is greater than the denominator. Yes, here it is greater. So if it is greater, divide the numerator by the denominator. So 2 3 times is 6, and the remainder is 1. So this can be written as 3 1 by 2, or it can also be written as 3 plus 1 by 2. So this is equal to 3 plus 1 by 2. So the integral part is represented as xb2 plus the fractional part is represented as f2. Now what is f1? f1 is 1 by 2, f2 is 1 by 2. We have to choose maximum of f1 comma f2. Now for this problem, since in both the cases f1 and f2 was 1 by 2, we will have 1 by 2 itself. Why are we doing this? We want to choose the source row. So whichever will be the maximum, that corresponding to that row, it will be chosen as the source row. Now since both are maximum, both are same over here, we can choose any of these two rows, that is the first row or the second row as the source row. So for I am going to choose first row as the source row. So that is row 1 double dash. This I am going to choose as the source row, and I am going to continue the problem. And why are we finding the source row? In order to generate a cut, we are finding this source row. Okay. So we have taken x2 as the source row. Then from the source row, we have to form a new constraint. Okay, so using this source row. So from the source row, we can write, so we will take the source row. Now what is the coefficient of x1? 0. So we will write here 0 x1 plus, here we have 1. So x2, okay, this is the source row. And then 7 by 22 s1. So plus 7 by 22 s1, 1 by 22. So plus 1 by 22 corresponding to s2 is equal to, so what will be the right hand side? It will be 7 by 2. Now using this, we are going to form a new constraint. Now since the coefficient of x1 is 0, you leave it. Then x2 plus, now 7 by 22. If you see, the numerator is lesser than the denominator, so have it as it is. So 7 by 22 s1 plus, here 1 also numerator lesser than the denominator, so 1 by 22 s2 is equal to, but here if you see, numerator is greater than the denominator, so write the integral part plus the fractional part, which will be 3 plus 1 by 2. We saw previously when 7 is divided by 2, we got this. So 2 3 times is 6 and the remainder is 1, and so it can be written as 3 1 by 2 or 3 plus 1 by 2. So by using that, I have written 7 by 2 as 3 plus 1 by 2. Now we have splitted this into integer part and the fractional part. Now consider only those which are fractions. So on the left hand side, this is integer part, because it is 1, so you leave it. Consider this because they are fractions, and on the right this also you leave. So this is a fraction, so we can write this as 7 by 22 s1 plus 1 by 22 s2, and this can be written as greater than or equal to 1 by 2. Okay, so this is because we are deleting this term, and so definitely this will be greater than or equal to this 1 by 2. So we have obtained this constraint, and we see that it is greater than or equal to. Now in order to make it lesser than or equal to, we have to multiply this throughout by -1. So minus 7 by 22 s1 plus, this also minus 1 by 22 s2 is lesser than or equal to minus 1 by 2. Now in order to make this inequality as equality constraint, we have to add a slack variable. And at this point, when we add the slack variable, it is known as the Gomorian slack. So we are going to add the slack variable g1 to this with coefficient 1. So it will be minus 7 by 22 s1 minus 1 by 22 s2 plus g1. So with coefficient 1, we are adding it, is equal to minus 1 by 2, because we want to make this inequality as equality constraint. So we are adding this Gomorian slack, and this equation will give us cut 1. So using this, we are going to proceed the problem. So this will be a new constraint, and this constraint will be added to the LP optimum table that we obtained in iteration 2. That is this table. This table we have obtained previously. To this table, we have x1, x2, and one other variable will be added to this table, that is g1. All other elements remain as it is. Now just we are introducing a Gomorian slack g1 to this table. So draw this table as it is with g1 over here, and g1, when we introduce it, we have to add here also, so g1. So kindly follow that. So I have written that in words. Now we are going to add this constraint with the LP optimum table that we obtained in iteration 2. So now I have taken the table that we have obtained in iteration 2 and I have written here as it is. So if you see, all these values remain the same. So I have written it as it is. Now the only difference is I have added a new Gomorian constraint g1. And what will be the cost of this g1? It will be 0 only in the objective function because it is a slack. And also in the cost here also, first initially we have to write 0 only. So after this, now this we have to fill. Okay, so now how are we going to fill it? Do we have g1 in the first constraint? No, so it will be 0. In the second constraint also we don't have it, so it will be 0. Whereas now next here we have to fill up. So for that we have obtained cut 1, right? So that we have to take. So this is cut 1. Now in this, do we have x1? We don't have, so put 0 over here. We don't have x2 also, so here also 0. But for s1 we have, what is the coefficient? It is minus 7 by 2. So fill it with that. So minus 7 by 22. Okay, now 22. Then s2 minus 1 by 22 is the coefficient. So minus 1 by 22. And then for g1 the coefficient is 1. So here you have to write 1. And the right hand side is minus 1 by 2, which has to be filled in the solution space. So minus 1 by 2. Now we shall find zj minus cj. So zj minus cj. Even that will also remain the same. You can directly copy it from the previous table. So it will be the same only. The reason is here we have 0 only, so it will not make any difference. So we can just copy it. And here you can put 0. So now this is Zj minus Cj. So this table is optimum, but it is not feasible. So now because it is not feasible, we have to apply the dual simplex method to recover the feasibility. So now this is why I told you in the beginning that you must know the dual simplex method in order to solve this. If not, also I will explain to you explicitly in this lecture, so please kindly follow it. In simplex method, first we will be finding the entering column. But now in dual simplex method, first we have to find the leaving variable. So which variable is going to leave this, and how we will be finding it? We have to check out the solution space. So in the solution space, we have to check out for the most negative element. And if we see in the solution space, we have only one element as negative. If there are more than one element, you check out for the most negative. Now, which is the most negative? This element. So, G1 will be leaving the basis. So, this is how we have to decide. Okay. So, after making the decision of the leaving variable, we have to decide the entering variable, for which we have to find a ratio. So, I will write that ratio over here. So, if you say I have introduced a new row which will give the ratio, we have to find the ratio Zj minus Cj divided by Aik. Now, what is this Aik? Aik are the elements of the leaving row. So, these elements are Aik. And very importantly, we have to choose only those elements which are lesser than 0. So, if you see, these elements are lesser than 0. This is the solution space, so we will not do for this. We will find the ratio only for these variables. So, when we see, these are the Aik elements, that is from the leaving row. In that we have to pick up only the negative elements, that is the elements which are lesser than 0. So, these are the values. For these two alone, we have to find the ratio, and the ratio is Zj minus Cj divided by Aik. So here what will be the ratio? Zj minus Cj is 63 by 22 divided by minus 7 by 22. So 63 by 22 divided by, we can make it a reciprocal and put it in multiplication, multiplied with 22 by 7. So 22 and 22 will get cancelled. 7 1 times, and this is 9 times. So it will be minus 9. So the ratio here is minus 9. Similarly, we have to find the ratio for this, that is 31 by 22 divided by this value. So multiplied with minus 22. So this and this will get cancelled. So here the value is minus 31. So out of these two, we have to choose the maximum. So minus 9 is the maximum. And minus 31 is lesser than minus 9, so we will not choose it. So minus 9 is the maximum of these two values, and so S1 will be the entering variable, because the corresponding variable to minus 9 is S1, and so that will be the entering variable. And the pivotal element is minus 7 by 22. So this is the pivotal element. So what we have done, I have written here, the table was optimal but was not feasible. So we applied the dual simplex method and we recovered the feasibility. So G1 leaves the basis and S1 enters the basis. Now we have to perform the normal row operations that we do in simplex method. So now G1 leaves and S1 enters. So at this place we have to replace it by S1. And then this will be, now we will take this as new representations as row 1, row 2 and row 3, and we will perform the row operations. So we move on to iteration 3, where we will drop G1 and we will introduce S1. So now first we will write in this iteration the YB column. We know that we already have X2, we also have X1. Now G1 leaves the table, and what has entered in its place? S1 has entered. And the cost is 10, 7. And the cost of the slack variable S1 in the objective function is 0 only. And Cj also here same only, 7, 10, 0, 0 and 0. Now we have to fill up these rows and columns by using the row operations. So we will take this as row 1 dash, and this as row 2 dash, and this as row 3 dash. In fact, we can draw lines to differentiate the rows, because here we have more than 2 rows. It's better to draw the lines and differentiate it. so that we don't get confused. So now first we will write the row operations. So first what is the step? We have to check out for the pivotal row. So if you see in this table, the pivotal row is the third row, that is row 3. Now from this row, first we should obtain the new pivotal row. So what is the new pivotal row? Row 3 dash. So that will be equal to the old pivotal row divided by the pivotal element. The pivotal element is minus 7 by 22. So this has to be divided by minus 7 by 22. Others also we will write and keep. So row 1 dash will always be equal to row 1 minus, so remember this, and this also row 2 minus. Now what is row 1 dash is equal to row 1 minus, you should see from this table. From this row, what is the element corresponding to the pivotal column? 7 by 22. So first you write that 7 by 22 multiplied with the new pivotal row. New pivotal row is R3 dash. So multiplied with R3 dash. So remember, to find R1 dash, it's equal to old row, that is R1. The old row corresponding to R1 dash is R1 minus the pivotal row column you should take, and the element from the pivotal column in that row is 7 by 22 multiplied with the new pivotal row R3 dash. Now what will be this? R2 dash, the old R2 minus, what is the pivotal element in the pivotal, the element in the corresponding pivotal column corresponding to row 2 minus 1 by 22. So that you have to write minus 1 by 22, minus into minus will become plus. So 1 by 22 multiplied with the new pivotal row. So that is R3 dash. So this is by the formula which I have already told in the beginning of the video. Now we shall perform these operations one by one. So R3 dash is equal to R3 divided by minus 7 by 22. So the elements of R3, that is, this is only row 3. All these elements I have taken and I have written here. Now these elements has to be divided by minus 7 by 22. You can also say that it has to be multiplied with minus 22 by 7. So minus 22 by 7 multiplied with R3. So these elements has to be multiplied with minus 22 by 7. So if you multiply this, minus 22 by 7 multiplied with minus 1 by 2, what you will get? 2 1 times, 2 11 times. So minus into minus plus. So 11 by 7. So we will take and write that here. So 11 by 7. We will go to the next element. It's 0 0. So both will be 0 because 0 multiplied with minus 22 by 7 is 0 only. So this also 0 0. The next element is minus 7 by 2. Minus 7 by 2 multiplied with minus 22 by 7. So it will become 1. So this value will be 1. And then for this element we have to do minus 1 by 22 multiplied with minus 22 by 7. 22 and 22 will get cancelled. Minus into minus plus. So 1 by 7 we will have. And then 1 multiplied with minus 22 by 7 is the same. Minus 22 by 7 only we will get. So we have obtained row 3 dash. Now for next we will find row 1 dash. For that first we will take and write row 1 from the previous table. The previous table we have here. So this is only row 1. So we will take these values and we will write. So I have taken and I have written R1 from the previous table. Next what we have to do? We have to find minus 7 by 22 multiplied with R3 dash. So that we will do here. Minus 7 by 22 multiplied with R3 dash. Now what is R3 dash? This one. So if you see, minus 7 by 2 multiplied with this. So minus 7 by 22 multiplied with 11 by 7. So 7 7 will get cancelled. 11 1 times, 11 2 times. So it will be minus 1 by 2. After that, here both are 0. So 0 multiplied with this will be 0 only. Both will be. Now 1 you have here. 1 multiplied with minus 7 by 22 will be minus 7 by 22. Then you have 1 by 7. 1 by 7 multiplied with minus 7 by 22. So 7 and 7 gets cancelled. So we get minus 1 by 22. Then minus 7 by 2 multiplied with this term. So minus 7 by 22 multiplied with minus 22 by 7. So these will get cancelled and we will get plus 1. Now we have to add these two because R1 minus 7 by 22 R3 dash is what we have to do. So just directly add it. So 7 by 2 minus 1 by 2 will be, LCM is 2, 7 minus 1 is 6, 6 by 2. So that will be actually 2 3 times is, so 3 you will get here. Then 0, 1 plus 0, 1. 7 by 22 minus 7 by 22, 0. 1 by 22 minus 1 by 22, 0. 0 plus 1, 1. So these are the values of row 2, row 1 dash. So we will take and write in the table. So you should take and write here. So I have taken and I have written here 301, 001. So these answers. Next we have to find R2 dash. What is that? R2 plus 1 by 22 R3 dash. So first we will take and write R2. So if you see, this is R2. 9 by 2, 1, 0, minus 1 by 22, 3 by 22, 0. So we will take and write that. So I have taken and I have written here R2. Next what we have to do? We have to add it with 1 by 22 R3 dash. So we will find 1 by 22 multiplied with R3 dash. 1 by 22 multiplied with R3 dash. So this is only R3 dash. With this, if we multiply 1 by 22, 11 by 7 multiplied with 1 by 22. 11 1 times, 11 2 times. So we will get 1 by 14. So that we will write here. Then next we have 0 0. So 0 0. The next we have 1. So 1 multiplied with 1 by 22 is 1 by 22 only. Then we have 1 by 7. So 1 by 7 multiplied with 1 by 22. So that will be 22 multiplied 7 is 14, 15, 154. So that is 1 by 154. So we will have 1 by 154 over here. And then we have minus 22 by 7. Minus 22 by 7. So minus 22 by 7 multiplied with 1 by 22. So it will be minus 1 by 7. Now we will add these two because it is R2 plus 1 by 22 R3 dash. So we have 9 by 2 plus 1 by 14 actually. We got here 14, no? Yeah, because 11 by 7 multiplied with 1 by 22, 2 times 7 to the 14 it was. Okay, so 9 by 2 plus 1 by 14. So the LCM is 14. Then here when we multiply by 7, 9, 7 times is 63 plus 1, which will be 64 by 14. So 64 by 14, we can cancel it 32 times and 2 7 times. So 32 divided by 7 we get here. And then 1 plus 0, so 1. 0 plus 0, 0. Minus 1 by 2 plus 1 by 22 plus 1 by 22 is 0. And then 3 by 22, so we will do here 3 by 22 plus 1 by 154. The LCM is 154 and this is 7 times. So 3 7 times is 21 plus 1, which will be 22 by 154. So when we cancel it, 22 1 times and this is 7 times. So 1 by 7. So we get 1 by 7 over here. So 0 minus 1 by 7 is minus 1 by 7. So these are the values of the new row 2 dash. Okay, we will take and write these values over here. So next we have to find Zj minus Cj as usual. So Zj minus Cj. So what will be that? 10 multiplied with 3, which is 30, plus, and then 7 multiplied with 32 by 7. 7 gets cancelled, 32, and this is 0. So 30 plus 32, which will be 62. For this column, 10 into 0, 7 into 1, 0. So 7 minus 7, so 0. 10 into 1, 10, 0, 0, minus 10, so 0. Then 0, 0 and 0, so this is also 0. Now then 10 into 0, 0, 7 into 1 by 7 is 1, and then 0 this is, so 1 we will get here. And then we have 10 into 1 is 10, 7 into minus 1 by 7, 7 gets cancelled, minus 1, this is 0. So 10 minus 1, which will be 9. we see that all zj minus cj is greater than or equal to 0. So we will take and write the solution. So this is the solution space. The value of x1 is 32 by 7, x2 is 3, and s1 is 11 by 7. And maximum of z is 62. So we see that all zj minus cj was greater than or equal to 0. The solution is optimal, but it is not integer since we have a fractional value for x1. So this is not an integer. So again we have to proceed the problem by constructing the fractional cut 2. So now we will do the construction of fractional cut 2, for which first we will take and write the solution x1, which is equal to, that is the solution which was a fraction, so which is equal to 32 by 7. We see that the numerator is greater than the denominator, so divide 32 by 7. So when we divide 4 times, we get 28 and the remainder is 4. And so it can be written as a mixed fraction, which is 4 quotient 4 by 7. So it can also be written as 4 plus 4 by 7. So which is equal to, the integral part is xb1 plus the fractional part f1. So f1 is 4 by 7. Next, what is the solution that is a fraction? S1 we have 11 by 7. So S1 is equal to 11 by 7, which is again 11 is greater than the, that is the numerator is greater than the denominator. So when you divide it, 7 1 times is 7 and the remaining you have 4, and so this can be written as 1 plus 4 by 7. Again the integral part is xb1 and the fractional part is f2. Here also both the fractional part is same only, that is we have to choose maximum of f1 comma f2, but here since both the values are same, the maximum value is 4 by 7. We can choose any of the row as the source row. Either x1 we can choose as source row or s1 we can choose as the source row. So arbitrarily I am going to choose x1 as the source row. So after finding the source row, what we have to do? Take the source row and form the new constraint. So x1 I am going to choose as the source row. So this row, what is the coefficient of x1 over here? 1. So 1x1, so we can write it as x1, and then we have 0x2. So plus 0x2 plus, next one is 0s1 plus 1 by 7 s2. So plus 0 s1 plus 1 by 7 s2, and then we have minus 1 by 7 g1. So minus 1 by 7 g1, and this is equal to, in the solution space what do you have? 32 by 7 in the source row. So that we have to write. So it's equal to 32 by 7. So we will rewrite it. So x1, so since this is 0 you leave it, and this is also 0, then plus 1 by 7. Numerator is lesser than the denominator, so 1 by 7 s2. Now here the next we have minus 1 by 7 g1. The fractional part should be positive only, it should not be negative. So if it is negative, what you do? We have minus 1 by 7. We have to rewrite it. How can we rewrite? You see the denominator. So take that. So you write minus 7, that is a minus the denominator. What if you add with minus 7? You will get minus 1. So plus 6 if you do, you will get minus 1. So minus 1 by 7 can be written as minus 7 plus 6 by 7. Using the denominator itself you write this. Okay, so minus 7 plus 6 will give us minus 1, and so we are writing it as minus 7 plus 6. Now separate the denominator for each term. So it can be written as minus 7 by 7 plus 6 by 7. So minus 1 by 7 can be written as minus 1 plus 6 by 7. So here minus 1 by 7 we have. So it can be written as minus 1 plus 6 by 7. We have to multiply g1 with it. So minus 1 into g1 we get minus g1, and then plus 6 by 7 multiplied with g1 will give us plus 6 by 7 g1 is equal to 32 by 7. And we see that after rewriting it like this, the fractional part is positive now. So that is very important. And 32 by 7 can be written as, while dividing, because the numerator is greater, you have to divide it, and we already saw that. So it was here 4 by 7. So it can be written as 4 plus 4 by 7. Next step, what we will do, we will consider only the fractions and we will leave the one which are integers. So this is integer, so you leave it. This is a fraction, so 1 by 7 S2. This is an integer, so you leave it, plus 6 by 7 G1. And since we are writing it like we are neglecting the integers, we can write this as greater than or equal to, neglect this 4 and you write the fraction alone, 4 by 7. Now we want to make this greater than or equal to inequality as lesser than or equal to. So multiply throughout by minus 1. So minus 1 by 7 S2 minus 6 by 7 G1 is lesser than or equal to minus 4 by 7. Now we want to make this as an equality constraint. So what we have to do? We have to add a slack. And what is that slack known as? Gomorian slack. Already we have added G1. So another Gomorian slack we have to add. So minus 1 by 7 S2 minus 6 by 7 G1 plus G2 is the new Gomorian slack that we have introduced, is equal to minus 4 by 7. And this is what? This is only this next constraint, which is cut 2. Okay. So now next what we have to do, this constraint, new constraint that we have found, has to be added to the LP optimum table obtained in iteration 3. So we know that in iteration 3 we have obtained this table. So to this table we have to add a new constraint G2. So here and here we will be adding as we did previously. So I will just add it and I will write the next table. So I have taken and written that table as it is, and I have just added this new row and column, that is G2. And what is its cost in the objective function? It will be 0 only. So here and here I have put 0. Now this in the first constraint, since it is a slack, this will have 0 only. Here also it will be 0. Whereas this row alone we have to fill from the previous constraint that we have recently obtained. That is the cut 2. What is that constraint? This one. We don't have x1, x2 over x1, x2, s1 over here. So all that will have 0 only. S2 has a coefficient minus 7 by 1 minus 1 by 7. So this also will have 0 only. S2 will have minus 1 by 7. And then G1. What is the coefficient of G1? It is minus 6 by 7. So this will have minus 6 by 7. And what is the coefficient of G2? It is 1. So 1. And what is the right hand side? Right hand side is minus 4 by 7. This we have to write in the solution space. So here we have to write it is minus 4 divided by 7. By mistake I wrote 0 first. This 0 I filled here. So minus 4 by 7. So write that. Okay. So now we have filled all this table. Now we have to apply the dual simplex method. The same procedure. In dual simplex method, what we will do? We will look into the solution space. In the solution space, the most negative value will be leaving the table. So here if we see, this is the only negative value. So G2 leaves the table. So after finding the leaving variable, we have to find the entering variable. So what we have to do? We have to find the ratio next in order to find the entering variable. So that is Zj minus Cj by Aik for only those Aik which are lesser than 0. And what are these Aik? Elements of the leaving row. Now if you see, these are the only two elements. We have to see only the variables, not this solution space. If you see only the variables, you can see that these two are negative. So only for these two we have to calculate Zj minus Cj by Aik. So what is Zj minus Cj for this? 1. So 1 divided by minus 1 by 7, which will be minus 7. And for this 9 divided by, we will write minus 6 multiplied with 7, because minus 6 by 7 we can write like this. This will be 3 times, 3 2 times. So 3 7s are 21. So this will be equal to minus 21 by 2. So now out of these two, the most negative will, the maximum. Out of these two, we have to choose for the maximum. That is the criteria. So maximum of this value. So which will be maximum? Obviously minus 7, because minus 21 by 2 is lesser than minus 7, it will be something like 10.5 like that. So it will be lesser than minus 7 because both are negative values. So minus 7 is the maximum out of these two values. So this will be the entering column, and this will be the pivotal element. Minus 1 by 7 will be the pivotal element. We can take this as row 1, row 2, row 3 and row 4 in order to perform the row operations and form the next new table, and we can check whether that gives us the optimal solution and also the integer solution. So let us proceed. So since the table was optimum and not feasible, we applied the dual simplex method in order to recover the feasibility. Now when we applied the dual simplex method, what we noticed, we saw that G2 was leaving the table and S2 was entering the table. So we have S2 over here. So S2 enters the table. So that is what I have taken and I have written. We shall now perform the row operations and we will form the new table. That is iteration 4. So I have formed a new table over here where G2 has left the table, and at the place of G2 I have replaced it by S2. And this we already know it. This is 10, this is 7, this is 0 and this is also 0 because its cost and the objective function both are 0. Okay, and then now we have to enter all these rows and columns. For that we have to perform row operations, for which first we should check out for the pivotal row. So what is the pivotal row? R4 is the pivotal row. So from this first we have to find R4 dash, and that is equal to R4 divided by the pivotal element. What is the pivotal element? Minus 1 by 7. So it will be R4 divided by minus 1 by 7. Now next we will write all this, that is R1 dash, R2 dash, R3 dash. So this is equal to, we have to write R1 here, R2, R3. So remember this procedure, and then minus you put. Then what we should do for R1, what is the element in the pivotal column? For R1 the element in the pivotal column is 0. So 0 multiplied with R4 dash. So it will be 0 only. So 0 multiplied with R4 dash, which will be 0. So we don't have anything. Next, for this, what is the element in the pivotal column? For R2 it is 1 by 7. So 1 by 7 multiplied with R4 dash. That is the new pivotal row. Okay. Then R3 dash is R3 minus, what is the element in the pivotal column corresponding to R3? It is 1 by 7. So 1 by 7 here, again R4 dash. So these are the row operations. So let us perform. Now row 1 dash is equal to row 1 minus 0. So that is row 1 directly we can take and fill up here. So what is row 1? These values 3, 0, 1, 0, 0, 1. We can just fill it up over here. So 3, 0, 1, 0, 0, 1, 0. So I have written that 3, 0, 1, 0, 0, 1, 0. Now this we have to perform. So let us take separately and we will do. So we want to find R2 dash. So first we will take and write R2. So what is R2? So from this table we have to take and write R2. So R2 is 37 by 7, 1, 0, 0, 1 by 7, minus 1 by 7, 0. So all these values let us take and write here. So I have taken and I have written. Then what? After R2 we have to write minus 1 by 7 R4 dash. So minus, let us find minus 1 by 7 R4 dash. So for that, first we should know what is R4 dash. That we have to do first. So I didn't do that. So first what you do, you find R4 dash, because when you have this column only, these two you will be able to find. Okay, so first we will do this, then I will come to this again. Okay, don't get confused. Since I didn't find this previously, I have to do this and then only I can come to this, because we have to make use of R4 dash over here. So let us do this. This is equal to what? R4 dash is R4 divided by minus 1 by 7. So just take R4. R4 is over here. First value is minus 4 by 7. So minus 4 by 7 divided by, we know that it is divided by minus 1 by 7. So minus minus gets cancelled, and so it will be 4. So let me write here. So it is 4. The next value is 0, 0, 0. So it will come as it is. So 0, 0, 0. What is the next value? Minus 1 by 7. So minus 1 by 7 divided by minus 1 by 7 is 1 only. And then we have minus 6 by 7. So minus 6 by 7 divided by minus 1 by 7. So it will be 6. So this value will be 6. And then we have 1. So 1 divided by minus 1 by 7. So it will be minus 7. So we have obtained R4 dash. So this is done. Now we have to make use of this R4 dash over here. That is, we have to multiply minus 1 by 7 with this R4 dash. So what we will get if we multiply minus 1 by 7 with R4 dash? So 4 into minus 1 by 7 will be minus 4 by 7. This is 0, 0, 0. 1 multiplied with minus 1 by 7 will be minus 1 by 7. Then this is minus 6 by 7. And then minus 1 by 7 multiplied with minus 7 will be 1. Now we have to add these two. Just add, because we have done that minus 1 by 7 with this itself. So just add these two. So both the denominators are same. So 37 minus 4 will be 28 by 7. But 28 by 7 is 4, because 7 4 times is 28. And 1 plus 0, 1, 0, 0. When we add this, it gets cancelled. So 0. Minus 1 by 7 minus 6 by 7 will be minus 7 by 7, which will be minus 1. 0 plus 1 is 1. So these are the values which has to be filled in row 2 dash here. So let us fill it. So we are done. So next thing that we have to find is R3 dash. For that we shall first write R3. R3 we have here. R3 is 11 by 7, 0, 0, 1, 1 by 7, minus 22 by 7, 0. We will take and write this. So I have taken and I have written R3. Next what we need? Minus 1 by 7 multiplied with R4. This is what we have already found here. So this we will just take and repeat it. So minus 1 by 7 R4 dash. So this is minus 4 by 7, 0, 0, 0, minus 1 by 7, minus 6 by 7 and 1. Now we will add these two. What is 11 by 7 minus 4 by 7? 11 minus 4, which is 7. So minus 7 by 7. And not minus 7 by 7, which is 1. Okay, then 0 plus 0 is 0, 0, 1 plus 0 is 1. When you add these two, they get cancelled. So 0, minus 22 by 7, minus 6 by 7. So minus 22 minus 6. So when added up, it will give us 28. So minus 28 by 7, which will be minus 4. And then 0 plus 1 is 1. So these are the values of that row. So let us take these values and fill it up in this row. So we are done with all the row operations. Now we have to find Zj minus Cj. So that will be what? 10 into 3 is 30. Plus 4 7 times is 28. So and these two are 0. So we can neglect these two. So 10 into 3 plus 7 into 4, 28. So 30 plus 28, which will be 58. And 10 into 0. And here we have to write these values. 7, 10, 0, 0, 0, 0. Okay. So now 7 into 1 alone we have here. So 7 minus 7, this will be 0. And here we have 10 alone, because all these are 0. 10 into 1 alone we have. So 10 minus 10, it will be 0 over here. And here 0, 0, 0, and this is also 0. So this row, if you see, it is completely 0. Similarly, this is also 0, and this one, 10 into 1, and then plus 7 into minus 1, so minus 7. So 10, these two are 0. So 10 minus 7 is 3. And then 10 into 0, 7 into 1. So which is 7 only. Other is all 0. We see that all Zj minus Cj is greater than or equal to 0. So all Zj minus Cj is greater than or equal to 0. And what is the value of Z? Z is equal to 58. This value. And value of x2 and x1 we obtain here. Okay. So x1 is 4. And then x2 is equal to 3. We observe that the solution is optimal, and also we have obtained the integer solution. X1 is an integer, x2 is an integer. We do not have a fraction as the solution. Hence, we have attained the optimality of the integer linear programming problem. So, therefore, the last solution is all integer, which is the desired solution. And this algorithm, that is the cutting plane algorithm, actually what it does is it modifies the solution space by adding the cuts that produce an optimum integer extremum point. Okay, so that is what we actually do. And we should also understand that the added cuts do not eliminate any of the original feasible integer points, but must pass through at least one feasible or infeasible integer point. So these are the basic requirements of any cut. So I hope you would have understood this problem. Yes, I can understand it is quite a very big problem, of course, but when you do it, when you bring it into practice, it will be very handy for you, and definitely you can do it so well. So you should have the knowledge of simplex method and the dual simplex method, but still I have done it explicitly in this video for your understanding, so that because of that reason also the video is quite long. So that is the method. So I hope this will be beneficial for your examination. Wish you all the best. Thank you.